So hello everyone, can you hear me? So I'll just wait for everyone to join. You have 2 minutes. You can ask me any of your questions in the live chat. I'll be here to answer them. And if you can hear me, please let me know in the live chat. Awesome. Thanks, Nikhil. So again, I have to go through this again. So hi everyone, I'm Sai Avinash. As I said, this is about in this lecture I'll be teaching about the second problem, a slightly harder variation of the previous problem. It's the frogs problem, frogs part 2. And I'll be in this lecture series. I'll be taking the dynamic programming course, and I'll be following the Atcoder DP contest, which has about 25, 26 DP problems, and it goes from easy to medium level. So there's that. And about me, I'm an SRE at Google Dublin. I'm currently working there. I'm already rank 4 at CodeChef. I'm a 7-star coder there. Max International Master at Codeforces. I'm currently a master, and I previously interned at Uber, and I'm also a Snagdon finalist. The subjects that I take are discrete maths, dynamic programming, graphs, and a lot of other competitive programming topics. So use the code SciLife to get 10% off on the Unacademy Pro subscription. Awesome. So there's college projects at every. So there's a show about by Raj Vikramaditya, Striver. It's a show at every Friday night at 10 p.m. and it's a part of the Unacademy's career as a software developer subscription. It's a $9.99 per year, and he's gonna pick up a few projects and he's gonna explain what's lacking and what's missing from your project and what you can do to improve them and so on. Right? So don't miss it. So there's this Telegram channel about where you can get live updates about all the videos that are coming up in this channel, and do subscribe if you don't want to miss it. Yeah, so that you don't want to miss any of the educational videos that will be really useful to you. Do subscribe for it. So if you haven't liked it already, and if you think it's going to be useful to you, please do like it and share it with your friends if they're also on the same boat as you, and do subscribe it if you haven't already. Frogs 2. I'll just wait for people to come in. I'll just wait for people to come in. I'll just wait for people to come in. Awesome. Shall I start then? Is everyone so is everything audible and everything clear? If it is, I'll just go ahead and start. Awesome. So your bestie is asking nowadays, code physics problems are more based on math, so what to do to improve DSA? So all I'll say is, like, practice problems that are challenging to you every day. That's what's going to push you, and that's what helped me do. Like, pick problems that are challenging to you in general. All right, don't just solve easy problems. Yeah, pick decent problems. Yeah. Awesome. Let's look at the problem frogs. Frogs 2. So it's a similar problem, but slightly different. Let's read the problem statement. There are n stones numbered from 1 to n. For each I, the height of stone I is hi. There is a frog who is initially at stone 1. He will repeat the following action some number of times to reach stone n. If the frog is currently on stone I, the frog jumps to one of the following stones, I plus 1, I plus 2, so on till I plus k, one of them. And here, the cost of hi minus hj, absolute of hi minus hj is incurred, where j is the stone to land on. Like j is the final stone, I is the initial stone, right? So j can be up to I plus k. J can be I plus 1, I plus 2, so on to I plus k. And the cost to jump is hi minus hj, right? Find the minimum possible total cost incurred before the frog reaches stone n. Here n is up to 10 power 5, k is up to 100, hi is up to 10 power 4. How would you do this? Let's look at an example here. 5, 3, 10. All right. Let's look at an example. Five, 3, n equals 5, k equals 3. K is the maximum jumping limit. Note that in the last problem you could have jumped only till I plus 1 or I plus 2. Now you can jump up till I plus k. You're generalizing the problem. It's a harder problem, clearly. Right. How would you do this? If, say, the numbers are, what do you say? 10, 30, 40, 20, 50, 20. 10, 30, 40, 50, 20. You want to reach here somehow. How would you reach? Know that you can make a jump of at most 3. You can't make a bigger jump. This is the highest jump you can make. How will you do it? So one way is to go from 10 to 30, and then from 30 you can directly go to 20. 10 to 30 is 10, because so 10 to 30 the cost would be 10 to 30 is just 30 minus 10, and from 30 to 20 the cost would be 30 minus 20, which is equal to 30. Now 10 to 40, if you do 10 to 40, it's already becoming 30 already. 10 minus 40 plus 40 to 50, 40 to 20 if you want to go. 40 minus 20, this is 40. It's bad. Now if you want to go from 10 to 50 directly, it's going to be 10 minus 50 plus 50 minus 20, which is really bad. So this is our best answer. We can't do better than this. The answer for this is 30, as you can see here. The path 1 to 2 to 5 is the best path, isn't it? Is the question clear so far? Any doubts with the question? So the question basically says there are n stones. The frog is at stone 1 and it wants to reach stone n directly, but sometimes it can't reach stone n directly because of how k is defined. Like you can make utmost jumps of utmost k. You can jump up till k stones. You can't jump further than that. And the cost to jump from one stone to another stone is the absolute difference of the heights of the stones. Now you need to minimize the total cost to go from 1 to stone n, to go from stone 1 to stone n. How would you do that? How would you do that? N is up to 10 power 5, k is up to 100, and so on. Let's look at how to do it. Awesome. What are you doing here? What are we doing here? So the question says before it was just simple. We could have jumped. You're jumping from here. You jump from 1 step or 2 steps. Now we can jump up to k steps. Now how do you do this? Anyone in the live chat? How do you do this? I'm waiting for your solutions. You need to be able to do this. Do it. Thanks, Durgesh, for the compliment. So I want you to tell the solution. I think Nikhil already has a solution. He told the complexity, so he must be having the solution, right? All right. Awesome. So the answer for 5. What did we do? So this problem, last problem is just the current problem with k equals 2, right? The last problem you can make jumps up to 2. It's the same as last problem. But here you can make jumps up to k. Right? Hi Siddharth. So here you can make jumps up to k instead of 2. So first problem, as we saw, prox 1, is same as this problem, but k equals 2 in that problem. Go to answer I plus 1 or I plus 2. So last problem we checked only up to 2 steps. Here we just check up to k steps. That's it. It's very straightforward. Right. We need to find the min for all k possibilities. Isn't it? Awesome. For example, I'll just take an example. So far, any doubts in the last problem or this problem, please let me know in the live chat. If there are no doubts, please say that it's clear there. So what you're doing here is, say for n equals 8 and k equals 3. Say the numbers are 2, 4, 3, 1, 7, 6, 2, 3. These are the stones. The circles are the stones, okay? Yeah, the stones, and on top of them, these are the h values. Say we want the answer, you can jump up to k steps. How? Let's start to fill the answers from the start itself. So the first answer is just 0, like you're just there. You don't need to pay anything to be there. Next answer. For being at this stone, you need to jump from the first stone. You can't be there for free. So the answer for that is 1. For this stone, you can either jump from the previous stone or you can come directly from the first stone. If you want to come from the first stone, the cost is 0. If you want to come from the second stone, the cost is 1 plus 1, which is 2. And minimum of 0, 2 is 2. For the second stone, we can come from either of the 3 stones because we can take at most 3 steps. We can't go further than that. We can take at most 3 steps. We can either come from 2, or we can come from 3, or we can come from 2. Again, from the start. So the answer is minimum of 2. 2 plus 4 minus 2. Minimum of, and 1 plus 4 minus 3 and 2 plus 4 minus 2. 0 plus 4 minus 2. This is the first step. This is the second step. Like, this is the first, second, third. And you can't take more than that. Right? You can't take more than that. So this is basically 4. And this is 2. This is 2. Right? Oh, wait. Sorry. The answer for 2 here is 0. So you can directly jump from this and you're paying 0 cost, right? You just make the 0. All right. All the answers are 2 here. So we fill 2 here. All right. Awesome. Let's see how we're going to do it for bigger n. How do we do it for bigger n? For 3, it's basically 2 plus absolute of 4 minus 3. 2 plus 4 minus 3 or 0 plus 3 minus 2. 0 plus, we can come from here or here or here. 3 minus 2 or 1 plus 3 minus 3. This is equal to 1, this is equal to 1, this is equal to 3. So the answer for 3 would be 1, the smallest among all of them. Let's write 1 here. 1. Similarly for 1, you can either jump from here or here or here. And you'll see that the answer would be optimal if you jump from here because 0 plus 1, 1. Similarly for 7, and so on. Like for 7, I'll just compute it quickly so that we quickly move on to writing the code as well. For 7, it's either you can jump from 1. For jumping from 1, it's 1 plus mod of 7 minus 6, or minimum of 1, 7 minus 6, and if you jump from 3, it's 1 plus 7 minus 4. If you jump from 4, it's basically 2 plus 7 minus 3. 7 minus 1, sorry, this is basically 7. This is basically 4. Sorry, this is 2 plus 1 sec. I missed it here. 2 and this is 1. Actually, I missed the numbers here. 3. This is the first jump, second jump, third jump. And you can't take more. You can take only up to k jumps, right? 1 plus mod 7 minus 3 is 5. 1 plus mod 7, 2 plus mod 7 minus 4 is also 5. So 5 is the answer. And for 6, similarly for 6, you'll get the answer as 4 if you look at it. You can take the jump from here. Because if you take the jump from here, it'll be 6. If you take the jump from here also, it'll be about 5. And if you take the jump from here, it'll be 6 minus 3 plus 4 is basically 4. So you need to print the answer 4. Any doubts so far? Any doubts with the solution? Any doubts? Do you want me to re-explain any part of this? I'll be happy to. I want you to get this clear. Everyone, is that clear? Thanks, Nikhil. Yep, glad to hear it's clear. So what is the solution? Given n and k, and you want to find the answer of n is equal to, what did we do for 3? For k equals 3, answer of n minus 1 plus absolute of hn, minimum of all of this. N minus 2, answer of n minus 3. You can go up till 3. You can't go further. For k equals 3, it's this. For k equals 2, it is only up to this. For any given k, it's up till k. Answer of n minus k plus hn minus hn minus k. So you can jump from the n minus kth stone up till the nth stone. For the jumping, the cost would be this, and to reach the n minus kth stone in the first place would be answer of n minus k. Good morning, Kapish. Yeah. So is this clear? Is this clear? This is the basic solution now. Any doubts with the solution, people? Any doubts with the solution? Is there anything you'd want me to re-explain? You need to understand the recurrence to actually get to coding, right? So, yeah. Other people in the live chat, is this clear? Awesome, awesome. 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 So let's get to coding on. So again, I'll do the recursive approach first. Again, see out, solve of n. And now let's fill solve. I'll do the recursive approach, the more intuitive approach. This is more intuitive to me. So here, yeah, int solve int n. Here we also have k. Let's write int k here. So for int, in base case n equals 0, return 0. Now for int I equals 0, sorry, I equals 1, let's iterate on the number of jumps. The number of jumps can be up to k. I plus plus if n minus I is greater than or equal to 0. Let's initialize the answer to a big number. Let's call it 189. Answer is equal to minimum of answer comma solve of n minus I plus you need to reach n minus I, and from n minus I you come to n again, and the answer for that would be, the cost of that would be absolute of h of n minus h of n minus I, and then you simply return the answer. Straightforward, right? Is this clear? Any doubts with this? Any doubts with this? Any doubts with the solution? Do you want me to re-explain any part of this? Is this clear? So what do I do here? It's a recursive approach. Like first we formulated the recurrence. Once we formulated the recurrence, we just put that into code. Answer of n equals answer of n minus 1. So we need this condition because the first k elements, you won't go up to, like for example, if k is about 50 and if you want answer of 7, you can't go from answer of minus 43 and all. So we just stop at answer of 0. That's why this condition is like the number of previous steps from n, how many steps you're going back, like from how many steps behind you're jumping here. That's what you need, right? So great, that's what you're doing. Answer would be minimum of all this or all i's, all jumps. I is the number of steps. You can call the steps as well, right? Let's call this steps is 1 step, 2 steps, so until k steps. Do you have any doubts with this part? Is there anything you'd like me to re-explain? Let's look at the complexity in a few minutes. All right. Finding the complexity, it's so again I'll tell you the complexity again. It's still exponential, but we'll just look at why it's exponential as well, and what kind of exponential it is. Percy is asking, can you explain if in the question, if it is like said modulo as answer is bigger, then we have to take modulo and just answer everywhere, calculate any variable in that code. Well, I didn't understand. I couldn't comprehend your question. Can you frame it more clearly? Like, yes, in the question, if they ask you to calculate, like usually the answer would go out of limits if you want to calculate the number of ways or something, usually. Or the number of, say, something like counting something. So yes, you have to take modulo everywhere. Yes, on all addition, yeah, on all the basic operations. Yes. Awesome. So what do we need here? For calculating answer of n, we're calculating answer of n minus 1. You're calculating answer of n minus 2. So until answer of n minus k. Right? Isn't it? What does this mean here? So before we just needed answer of n minus 1 and answer of n minus 2. Now we're calculating all the way up till n minus k. So the complexity of this would be basically calculate answer, the number of steps for n is equal to c of n minus 1 plus c of n minus 2 plus so until c of n minus k. You could say that as k gets close to n, this would be close to O of 2 power n. This would be nearly O of 2 power n. You can assume that it's 2 power n. Why? Because if you look at it closely, for smaller k, it will be some other value between 1.618. So this is we can say that if answer of n is equal to answer of, like, if you what do you say? Look at these two recurrences. C of n is equal to C of n minus 1 plus C of n minus 2. This is the first recurrence in the previous problem. In this problem, it's C of n equals C of n minus 1 plus C of n minus 2, so on till C of n minus k. So this, since the base cases are the same, this and this is definitely going to be greater than this. This C of n is going to be greater than this. Right? Alright. Meaning it's going to be exponential, but it's going to have a bigger number, bigger than 1.6. Like this Fibonacci, right? Fibonacci. And let's look at another, let's look at what this is going to be. Like, it's going to be close to 2 power n, and I'll tell you why. Because, let's look at 2 power n. So 2 power n is equal to 1 plus 2 power 0 plus 2 power 1 plus 2 power 2 plus so on, right? 2 power n minus 1. And how is that happening? 1 plus 2 power 0 is 2 power 1. 2 power 1 plus 2 power 1 is 2 power 2. 2 power 2 plus 2 power 2 is 2 power 3, and so on. Here we get 2 power n minus 1 plus 2 power n minus 1. We get 2 power n. So if C of n is equal to 2 power n, we get C of n is C of n minus 1 plus C of n minus 2 plus C of n minus 1, so on till C of n, C of 1 plus C of 0, right? So since the base cases are the same, this would like converge to 2 power n of 2 power n as k is high and high, right? So this will be O of 2 power n, and that's not favorable to us. Is this part clear? Do you want me to re-explain this part? I would be happy to re-explain this part, like if you really want to know what it means. All you need to know is it's exponential and it's not feasible, but it's good to know how the complexity is formed too. Awesome, it's clear. Awesome. All right. So the complexity of this is clearly 2 power n. Now how do we do this better? Same, let's do the DP method. Int DP. We store it again, dp.resize n. Now DP of, we just bring it in everywhere. We just need to resize everything. Don't forget to initialize everything to -1, okay? That's very important. Now DP of n equals answer. Return DP of n. Here basically we stored answer in DP of n, and we know that DP of n is not going to be -1 if the answer is computed. If DP of n isn't -1, meaning this says all right. Is this clear? So this makes the complexity from nearly of 2 power n, like introducing DP, like introducing memorization, gets the complexity from near 2 power n of 2 power n to O of n into k. You can see that at each step for each n you're doing k steps. Like for one n you're coming in exactly once, but once you come in you're doing k steps, right? So each n you're doing k steps almost for all n of n into k. For the initial few elements you probably won't do all the k steps, but that's only for the initial few elements. For O of n elements you're likely going to do all the k steps. All right. I'll just re-explain the code. First I took the input, initialize the DP array to -1 because I want to know something to tell. I want to know, like I want to know a deciding factor, like to tell that, hey, have I computed for this n? If it goes in here, it means that I haven't computed. If this check fails, it means that like this check is asking the computer, hey, have I computed for n? Then the computer says, if the computer goes here, it means that, if the program goes here, it means that, no, I haven't computed for n, let me compute it now. If it goes here, it means that, okay, I've already computed it, let me not compute it again. I'll return it quickly because, yeah, it's going to save me time. And because I've coded it, it's coded there, yeah. Yeah, Nikhil, difficult questions are coming, like they'll come. So since this is for everyone, I wanted to start from the real basics. Yes, I know these are easy ones, yes. I'll just make this iterative. Abhishek, I prefer you study DP first. I mean, there's no order, you can study both of them parallelly if you have time, but I prefer DP first. Yeah, dynamic programming first, like it's one of the crucial tools for problem solving, right? So yeah. Now for int DP of 0 equals 0. But we are making this iterative now because the stack depth can go up till n. Let's make this iterative. I less than n, I plus plus. Let's just copy this directly. You can copy this directly, but I'll write it like it's. I'll just write it now. Int steps equals 1. Steps less than or equal to k. Steps plus plus. If I minus steps greater than or equal to 0. Int answer equals 1e9. So I initialize the answer to 1e9. Answer is equal to minimum of dp of I minus steps plus absolute of h of I minus h of I minus steps. Awesome. Answer is equal to minimum of these two answers, right? Like you jump from I minus steps, number of steps before, you jump to I, or you try all the values and you take the minimum, the smallest answer, and then you store that in DP of I. Now you just print DP of I. I'll just explain the problem for people who haven't come here, who just came here. So there are n stones numbered from 1 to n. For each stone, the height of the ith stone is hi. And just explain the problem here, like just to remember what happened. For the frog at stone 1 wants to reach stone n, and if the frog is currently at stone I, it can jump at most k steps ahead. And on top of each stone, the stone I is of height hi, and for the frog to jump from stone I to stone j, the cost incurred is the absolute difference of the heights. Like absolute differences, note that. So you can jump at most k steps ahead. You want to reach from 1 to n, but you can't. Sometimes you might not reach it directly because of the bound of the number of steps, because of the number k. You want to find the minimum number of steps, minimum cost. Like you have to pay cost if you jump from stone I to stone j of cost absolute of hi minus hj. So you need to make a few jumps to reach from 1 to n. That's what the question is. And what we did was we just made a recurrence relation of answer of I. Answer of I is minimum of either answer of I minus 1 plus absolute of hi minus 1, like the cost to go from I minus 1 to I, or answer of I minus 2 plus cost to go from I minus 2 to I, and so on. Answer of you jump from I minus k. So first you need to reach I minus k, which is answer of I minus k, plus absolute, like the absolute difference of hi and hi minus k. That's what. And you take the minimum of all of them and then you reach our answer here. This is clear. Is this clear so far? Is this clear? Any doubts so far? Awesome. Awesome. All right. All right. So if this is clear, then I guess we can move on to the next problem. It's more of a div to C level type problem. It's not too hard, but it's a basic DP problem again. So if this is clear, let's move on to the next problem, I guess. Yeah. Awesome. Then I guess so do subscribe to the channel. If you have any doubts, please do drop them in the in the comment section. I keep a look at them. So please do subscribe to the Telegram channel to get live updates on classes. And if you haven't liked it already, and if you think this lecture was useful to you, please do like it and share it with your friends who just like beginners or yeah. Thank you. I'm gonna take the next class in about 5 to 10 minutes, so stay tuned.